Hello everyone, and let's solve today's uh, lead code problem of the day, which is named as predict the winner. Okay, so you are given an integer array nums, and basically two players are playing with this array, player one and player two, and player one will take turn first. Okay, and then player two, and they are taking turns one by one. Okay, with player one starting first, both players start the game with a score of 0. Means initially their score would be 0. At each turn, the player takes one of the numbers from either end of the array. Means either from the starting, that is nums of 0, or either from the end, nums of means at back of the array. Okay, which reduces the size by the array by 1. Means also the since the player has chosen either of the ends, so that end would get removed. Okay, so the size would be reduced by this 1. Okay, the player adds the chosen number to their score. Okay, the game ends when there are no more elements in the array. When there doesn't left any element, then the player whose score would be high, that would be the winner. And suppose return true if player one can win the game. So we have to determine if player one can win the game or not. Okay, so also there is a tiebreaker. If suppose what if the scores of both the players are equal, then it has been stated that player one is still the winner, and you should return true. Okay, and one thing you should assume that both players are playing optimally. Playing optimally means what? Both are playing in such a manner that they will become the winner only. Okay, and just try to reduce the score of the other player. So for first example, let's see 152. Since it is 152, since player 1 will start first, either he will choose 1 or either he will choose 2 first. The second player will obviously choose 5, and his score will be higher than the player 1, than that of the player 1. So we can't just win here. Okay, so I hope the question is clear. So one thing I would just say that whenever you encounter a problem where there is a choice, means you have been asked some, you have been given some options, and you will have to choose one option at each of the steps. Then dynamic programming should come to your mind. Okay, so we are going to solve this using by dynamic programming, because there is a choice, and we don't know by choosing which choice, means choosing which option, it will be beneficial for the player. Okay, we don't know at present. Okay, and how I will solve is that, suppose if the sum of the numbers of the array is sum, and if I just obtain an answer variable, means score of the first player, score of first player. So if it is greater than equals to, why equals to, because it has been stated that even if the scores of both the players are equal, then the player one will be still the winner. Okay, so if I say if answer is the score of the first player, then sum minus answer will obviously be the score of the second player. Okay, so if I say that, so what I want, uh, what would be the condition for the first player to win? Obviously, the score of the first player should be greater than equals to sum the total score minus the score of the first player, because this will be the score of the second player. This would become sum minus answer. So why not just find the maximum answer, means the maximum score we can obtain for player one. And if even if he is not able to win with the maximum score he can get while playing optimally, then I can be so sure that he can't win the game. And if there exists some strategy where the player one can get a score, means answer, in such a way that this condition holds, then obviously there is a chance that player one, if the player one plays in this manner, then he will win. Okay, so using dynamic programming, I will just try to find the maximum score answer, which is answer the which the player 1 can get if he plays optimally. So let's move to the whiteboard and explain it. So the first example is, it is 152. Just see how I am solving. Okay, now there are two options. There are two options for the first player. It is the turn of player 1. Let's name it as P1 itself. Okay, P1. So if you choose 1, if you choose 1, then what would the array look like? It would be look like some 5 2. Okay, 1 would get erased. And if you would have chosen 2, then the array would become 1 comma 5. Now it's the turn of the second player. So again there would be two options for the second player also. If you would have chosen 2, then the array would be become, if you would have chosen 5, then it would become 2, and if you would have chosen 2, then it would, okay. Okay, now I will also show you that how the uh, overlapping occurs in DB problem. Okay, it would become 1 if you would have chosen 5, and it would have become 5 it would have an 1. Okay, so one thing you should observe here is that again the state is same. Again the state is same. It is the array 5. It is the array 5, and it's the turn of the player 2. That's why the dynamic programming would be applicable here, because if you memorize it, that's the requirement of the memorization, because here you can see there are some overlapping. Okay, there are some overlapping. Okay, so now we are now comes the turn of the third player, and we are left with only, and we are left with only one element, and we are left with only one element. So what would happen? One thing you should observe, and suppose you are playing, then in your turn you would try to get the maximum. You try to get the maximum. Okay, and in the second turn, how I have defined DP? I have defined DP just to find the maximum score the player 1 can get. Okay, so what I will do, if it is the if it is the turn of the second player, so obviously it would not contribute to the score of the player 1. So in that case I would just sum 0. Why? Because that would not contribute to the score of the first player. Okay, and if it is the turn of the player, sorry, it was player 1. If it is the turn of the player 1, then he would try to get the maximum possible. Okay, so he would take 2 here, and he would take 5 here. It is the turn of player 1. Now here comes the turn of player 2. Why I am assigning it as 0? Why? Because it would not contribute to my score of the first player. Why? Because it is the turn of the player 2. Now here is a twist. What the player 2 will try to do, he will just try to minimize the score of the player 1. He will try to minimize the score of the player 1. So in that case the player 1 would get minimum score. Minimum score. That's why here are two options, 2 and 5, but player 2 would get, minimum of these two. So obviously from here 2 would get returned. Okay, similarly, here player 1 would have chosen 1, player 1 would have chosen 5 if that was the case. But since now player 2 turn has been came, then player 1 would have played in such a manner that player 1 would get the minimum score. So these from this example, means from this state, minimum these two, means 1 comma 5 would have returned. Okay, so 1 would have returned. Now again here comes the turn of player 1. Okay, so he would choose the maximum. What I have chosen 1 here, and what I have chosen here 2. Okay, if I would have gone here. Then now again I would just because it is the turn of the player one, so this would add up to the score of the player one. So now add this. Suppose I am coming out of this array, then what I can say, there are two options. 2 plus 1 is equals to 3 from this part. 2 plus 1 is equals to 3 from this part, and here here 1 plus 2 3. So I can say that the maximum score the player one can acquire is maximum of these two, maximum of these two, maximum of these two. Okay, so it would be 3. So, and also you can observe from the naked eye also that the maximum score the player one could get is only 3 by choosing these two. You can't, it doesn't matter how he plays, he will not be able to choose 5. Okay, so that's about the states, and let's move on to the solution. Int n is equals to nums dot size. Suppose name that score. Score is equals to 0 for the maximum score of player 1. Okay, now I will just create a store this in the variable. I will just create a function which would return the maximum score the player 1 could obtain. Okay, so the at first what would be the range of the array? It would be obviously L to R, L to R. Okay, and now if he chooses suppose L, then what would be left? It would be L plus 1. It would be L plus 1 comma R. It would be L plus 1 comma R. Or either if you would have chosen last index, then it would the array would become L comma R minus 1. L comma R minus 1. Now one thing I want to explain you. Suppose the range is L comma R. L comma R. L here and R here. Okay. Initially the L comma R was here. Okay. So if it is the first the turn of the player one comes, then there are two conditions. Either you would choose an L, either you would have chosen L, then it would have become L plus 1, L plus 1, as L plus 1 to R. Or either you would have chosen the last index, then what it would have become R minus 1, R minus 1. Okay. Now the again the turn of the player 2 comes, then there are two options in this array also. What it would have become, either he would again he would also have chosen from the starting index. So now the array left for the player 1 would become L plus 2 to R. Okay, L plus 2 to R. Or if you would have chosen from the end, then the array left for the player 1 would become L plus 1, whatever, L plus 1 to R minus 1. Okay, and now in this case also, if you would have chosen from the starting, then what would be the range would become? It would become L plus 1, L plus 1 to R minus 1. If you would have chosen from the starting point, or if you would have chosen from the end, then what would be the array left for the turn of the player 1? It would have become L comma R minus 2. So that's the same thing I will just do in this case also. Okay, so In the starting, the range is like this. So finally I would have to return, but before this I would have to just store the max total score. Int total is equals to 0. This is the total sum of the nums. Now for auto ampersand it nums total plus equals to it. So what would I have to return? I have to check whether the score of the player 1, the maximum score of the player 1 is greater than equals to total minus score, means it will be the score of the second player. If it is greater, then I have to return true. Okay. Now let's create the solve function. Int solve int l comma int r and then vector ampersand nums. Now if L has become greater than R, then in that case I wouldn't have left with any element. So in that case I would have to return 0. Okay. Suppose if I am left with only a single element, that in that case only I would have to return nums of. If it is a single element, then obviously I would have to return only that element. Okay. Now if it is not so, then I would just score is equals to 0. Now I am assuming that this is the turn of the player 1. So maximum of just see what I'm doing. Maximum of score comma, suppose I have chosen from the L, the starting index. Then I would have to take the minimum. I have explained, then I am assuming that now it's the turn. This is the play for the turn of the second player. So if the player 1 would have just completed his turn, so what would I have been left with? I am defining here. Okay. So in that case, since uh, the whatever the element the player 2 will choose, that will not contribute to the score of the player 1. That's why I have not added anything. Here you can see I have added to my score nums of L, but in that case it would I would have not uh, I would not add any element, because that would not contribute to my player 1 score. It would contribute to player 2 score. So now if he would have chosen, now here comes these four cases. Here comes these four cases. I would have to just. So first case was what? I have chosen L for the player 1. So what the two states left here? L plus 2 comma R and L plus 1 comma R minus 1. So that's the only thing I will just do. L plus 2 comma R, L plus 2 comma R comma nums. And second option was what? Option was L plus 1 comma L plus 1 comma R minus 1. Okay. And now the second option was for the player was that for the player 1 was that just to take the element from the end. So in that case also this was the case. So L plus 1 comma R minus 1 and L comma R minus 2. Minimum of solve of L plus 1 comma R minus 1 and L comma R minus 2. L comma R minus 2. So one thing I forgot, here it was nums. Here it was nums. And just I will return the score. Okay, so let's run it. So yeah, it is giving correct answer. Although I have not memorized it, I will have to memorize it. Otherwise, it will lead to TLE. It will be exponential time complexity without memorization. Yeah, it is giving right answer. So let's memorize it. Vector of vector in dp. Now dp is equals to vector of vector in plus 1 comma vector of n plus 1 comma minus 1 means I have to initialize with a value that can't be possible for the score. Obviously minus 1 can never be possible a score. So if dp of l comma r is not is equals to minus 1, then in that case just return dplr, because I would have uh, obviously pre-computed that, though, so it doesn't make sense to just compute it again and again. That's the concept of the memoization. So let's run it again. Let's submit it. So it got accepted. Talking about the space complexity, it will obviously big of n square, and talking about the time complexity, it would be I can say it would be n square, because of these two. I am running a loop for L and running a loop for R, so it would be big of n square solution, and obviously the n square solution would pass because n is quite low. Okay, so thank you.